All right, so let's do one question that has reciprocal, right? This one is a secant, right? Secant, question 30, okay? Secant 7 pi over 12. Okay, so secant is the reciprocal of which one? Lady? Secant is 1 over...
one over secant is 1 over cosine.
Yes, okay. Secant and cosine is like a brothers, okay? Cosecant and sine, brothers, right? So this one, right, they give you a secant, but we are going to write it as 1 over cosine first. Okay, because you remember secant is reciprocal, but very common mistake is to reciprocal the angle, okay? So please write it on the top, okay? Secant of 7 pi over 12 does not equal to cosine 12 over 7 pi, okay? You never flip the angle, okay? Never flip angle, okay? Very important. Okay, do not flip the angle. It's 1 over the whole thing, all right? So the correct way is to write it as 1 over cosine 7 pi over 12, okay? The angle stays the same. Okay, everyone got this down? So instead of doing secant, we are gonna work on cosine now, okay? Because we don't have identity for secant, right? We only have cosine. So please draw a line here, okay? We'll do cosine 7 pi over 12. And then do not change to degree, okay? We're just gonna work with 7 pi over 12. So you either use sum or difference, okay? You decide. It will be co, right? Change, sine, right? Co. I shouldn't write just C, right? Co, change, sine. Okay, it's either using adding or using subtracting, you decide. Okay, let me erase that first. Okay, so I'll let you try this out. This is similar to your homework. Okay, 7 pi over 12, how do you split the angles? And then find each of the ratio. Okay, so please figure out what are the two angles that can make up 7 pi over 12. If you found the two angles, please raise your hand. Okay. Let's confirm on the angles first. Okay, Philip, what are the two angles that you chose?
Pi over 3 and pi over 4.
Okay, add or subtract?
Add.
Okay. Is there anyone using different ones? Let me know if you are using different ones. Of course, you can do subtracting, okay? I think this one, yeah.
Oh, I did 3 pi over 6 minus pi over 4.
3 pi over 6 minus
Pi over 4.
pi over 4. Let's see. So
This
that
is 150 minus 45.
we're not using degree, right? You still change the degree.
Oh no, I didn't change. I just left it as it is.
Oh, 3 pi over 6 minus pi over 4.
Yeah.
Okay, so this one will give you, how does it become 7 pi over 12? This will be 12 and 6 pi, right? Minus 12 and 3 pi. And that gives you 3 pi over 12. How's that 7?
Oh, okay. Um,
Do you see I wrote it here?
yeah.
Yeah, right? You want to make 7 pi over 12.
Okay.
Okay, so those two, yeah. Anyone else want to check if your pairs are correct? Anyone got different ones? Usually, if you want to have a denominator of 12, right, you will choose 3 and 4, right? 3 and 4, their common denominator will be 12. And then you just think about whether you should be adding or subtracting, okay? All right, so let's move on, right? So sine, sum, and difference, we have our A and B, right, over 4. Adding, right, because, sorry, should be change. Okay, see, very easy to make a mistake. Call change, right? So if it's sum, we need to just subtract. Change sign. So just put it in order. So please go all the way, right? Find the exact value for each one, simplify it, and put it as one fraction, okay? Once you get to that point, please raise your hand. Okay, let's check the ratios, all right? Cosine pi over 3, let's start with that. Cosine pi over 3. Nick, what's the ratio for that? For the first blink, cosine pi over 3.
Root 3 over 2.
No, cosine pi over 3. Did you draw out the triangle?
Oh, 1 over 2.
Yeah. Okay, pi over 3, the opposite sign should be root 3. Okay, opposite side. Okay, cosine pi over 4. Caleb, cosine pi over 4.
Square root of 2.
No.
Oh, cosine.
Yeah.
Square root of 2 over 1.
Okay, pi over 4. If it's pi over 4 in the triangle, right? Look at the screen, pi over 4. What are the two sides? What are the three sides?
Oh, 1 and square root of 2.
Yeah, where do you put the square root 2?
Oh, on the hypotenuse.
Yeah. 1, right? So cosine is which side over which side?
Oh, adjacent over hypotenuse.
So
It,
what over what?
Oh, 1 over square root of 2.
Yeah. Okay, and then sine pi over 3. Chris?
Root 3 over 2.
Okay,
I don't-
Waylon, next one, sine pi over 4.
Root 2 over 2.
Look at the triangle.
Oh, one sec.
Sine,
1 over root 2.
yeah, 1 over root 2. If you use the calculator, then it will just simplify it for you for some calculator, okay? It will rationalize, okay? I don't want you to do that, all right? There's some questions, okay, on the test, they will say no calculator allowed. So you need to know how to do it without a calculator, okay? Otherwise you will panic, right? What happened now? I don't have a calculator. Okay. So now let's simplify this. Okay, first two fraction times together, you get 1 over 2 root 2, right? And then the other one is root 3 over 2 root 2. That will give you 1 minus root 3. Denominator is the same, right? 2 root 2, 2 square root 2. Okay, can you raise your hand if you agree with the answer so far? Okay. But we're not done yet, okay? So just make sure you got here, okay? Raise your hand if you got everything up to here. Okay, and then we are going to move back, right? Remember we did the cosine, but then the question was secant. So we need to bring our answer here, the green one, okay? And then plug it back to there, meaning you need to reciprocal, okay? So secant will be the reciprocal of your answer that you just got. So equal to, you flip it, right? So 2 root 2 should be on top. 1 minus root 3 will be at the bottom. All right. Any questions so far? We are still not done. Okay. What else do we need to do now, Daniel?
You have to rationalize the denominator.
Very good. How do we do that then?
Do you like multiply by the conjugate?
Yeah. Okay. So denominator has a 1 minus. We need to multiply with a 1 plus. Okay. 1 plus root 3. 1 plus root 3. Okay. I hope I have enough space. Okay. So for the denominator, this is using the formula. Okay. A minus b, right? 1 minus root 3 times 1 plus root 3 will give you a squared minus b squared, right? So a is 1 minus b is root 3, b squared. Okay, what about the top? The top you just distribute one by one. Okay, Claire, can I have you try the numerator?
Two. Wait, actually, wait. We haven't started this one.
Start what?
Were we supposed to finish doing this before? Wait. Oh, so it's okay. Two.
Yeah.
Root 2
Yeah.
plus 2 root 3 root. Oh wait.
The inside can times together. The number.
Oh yeah. 2 root 6.
Yes. Okay. So when you're multiplying square roots, outside number times the outside number, okay, inside number times inside number. Only for multiply and divide, then you can do that. Okay, add and subtract, you can't. Okay, any questions so far? All right, let's simplify a bit more. Okay, the top will keep it there. Denominator, okay, 1 square is 1, right? Root 3 square is 3. So 1 minus 3, -2. Does anyone have questions so far? All right, so now because the 3 parts, the numbers on the outside, right? All these are the number on the outside. They are all divisible by -2. So we need to divide it, okay? If one of the 3 is not divisible, you cannot reduce, okay? This one, they are all possible to reduce it. So the first one, 2 divided by -2 will give you -1. The second one as well, okay? So become this. So your final answer, you should always simplify. Okay, not just reciprocal and leave it, right? You have to simplify it, rationalize it, okay? Simplify as far as possible. Okay, can you raise your hand if you got everything so far? So this is how you deal with secant, okay, cosecant, cotangent, using sum and difference. You have to use sine, cosine, right? Cocosine, sine, those ones first, and then flip the ratio, okay? So this one, pretty straightforward, you just plug into identity. We'll look at another type of questions. Still using identities, okay, but they ask you to use it in a different way, okay? So if you compare this question with the previous question, okay? Here, question A, let's have Evan, can you help us read this out? Question 31A.
If angle A and angle B are both in the second quadrant, sine A equals 3/5 and cosine B equals -5/13. Evaluate cosine A plus B.
Yes, okay. So they want you to find, right, evaluate cosine A plus B. Kind of similar, right? Cosine, they want you to find, okay, let's go back. Right, cosine A plus B. But what's the difference is we don't even know what's the A, what's the B. Right, normally you find it, right, by splitting it, right? They give you an angle there, right? 5/12, 5/12, you split, and then you have the A plus B. But for this one, does it give you angle? Marcus, do you know any angle in here? Marcus?
The 3/5.
Is 3/5 the angle?
Can you like change it?
How do you change it? What do you mean?
Oh, never mind.
So do we know the angle here?
Kind of. I mean,
Where?
they're both in the second quadrant.
Yeah, we know the angle in the second quadrant, yeah. But do we know how big they are?
No.
No, right? So for this one, the difference between this question and all the question we've done before is we don't know the angle. So what should we do then? Any plan? Anyone have a suggestion? If we don't know the angle, how can we use the identity? Anyone?
Can you use cosine law to find the angle?
Use what? Which one?
Cosine law.
Cosine law. How do we do that?
So if you draw the triangle and get all 3 sides, then you can plug it into the cosine law. So a
Oh,
squared equals b squared plus c squared minus 2bc
oh, so okay,
cosine.
I see. Okay,
Yeah, that.
yeah. Okay. What kind of triangles? Okay, so but for these ones, they are all right triangles. Cosine law is for,
Oh, I just realized you can just do sine inverse 3/5.
okay, yeah. So for example, if it's
And
sine angle A, 3 is here, 5 will be here, right? And then you can do inverse to find the angle. Sine inverse 3/5 can give you A. So if you do that, the angle, is that a nice angle, like exact numbers? Is 3/5 a special angle? The ratio for the special angle. Lady? If you
No.
inverse the 3/5, would that give you a good angle? Can you try it out?
Pardon?
Can you try it out? Sine inverse of 3/5. Can you tell us what you got?
$36.869.
869, and it keeps on going, right?
Yeah.
Yeah, okay, thank you. So you can see that the 3/5, the ratio that they give you here, it's not like square root 3/2, right? 1/√2, those special angle, okay? So these ratios, okay, these ratios are not special. Okay, same with this one. So even if we find the angles, I still cannot use it, right? Because our goal is try to find the exact value for A plus B, okay? So this is telling us we don't need to find the angle, right? Because even if we find it, we can't use it. Okay, anyone else has come up with an idea now what to do? Now, if we don't want to find the angle, right, you need to know why we don't need the angle, okay? It's not special. What should we do? Let's look at each of the ratio here. We have someone saying something. Okay, Jenny. Okay, so let's grab each one first. Okay, we'll look at the picture for each one. We at least we know it's in the second quadrant, right? So let's draw it out. Let's start with sine A. Okay. So it's in the second quadrant, right? So the picture will look like that. So the angle A will turn to there, right? This is angle A in the second quadrant. For angle B, right? Both of them are in the second quadrant. So we'll turn to there as well. Of course, their angles are different. Okay, we don't know which one is bigger. Angle B. Now, because they tell you the 3/5 is for the sine, right? So you can fill that in. Opposite over hypotenuse. Okay, cosine is adjacent over hypotenuse. Adjacent over hypotenuse. It has a negative, right? Negative is for the adjacent side because it's on the left side, right? You can put a -5 there. Hypotenuse is always positive, okay? Everyone got this part? This is as far as we can do, right? Based on what information that they gave us. Second quadrant, They also give you the sides, okay? So we can draw this out, okay? We are trying to collect all the clues. Okay, you can draw the line here. Now let's look at how would that help us to do cosine A plus B. Okay, so when you see cosine A plus B, what is the identity for this one? Sophie, what's the identity?
Coco change sign.
Yeah, so it will be cosine, cosine, and then plus or minus?
Minus.
Yeah, minus sine, sine. Okay, Coco. Change sine, sine. Okay, sine, sine. And since we don't know the angle, right? So there's no way to fill in the A and B, but we don't really care, right? Because we are interested in ratios. So in fact, we can actually skip to the next step, because the next step is to find the ratios. You see what I mean now? Even without knowing the angle A and B, our final goal is still to find the ratio only, right? And the picture on the left side, right, the two pictures, they tell you the ratios for each angle. So for example, cosine A. Okay, so you look at on the left side, if I want to find cosine A, Waylon, which picture should I look at? Do I look at the top one or the bottom one?
Is it bottom?
Does the bottom one
Wait.
have angle A?
Never mind, cos sine A.
Yeah, we look at the picture on the top, right? That's for angle A. But we want to get cosine. So cosine is what over what?
Adjacent over hypotenuse.
Okay, so in that picture, do we have adjacent and hypotenuse?
No.
Can we find?
Wait, yeah, we do.
Okay, what's adjacent?
-5.
Where did you see -5? We're doing looking at the first picture. The top, right?
Oh wait, is that 3, 4, 5? So like the one sec. Yeah, isn't the adjacent 4?
Adjacent is 4. How did you find that?
Pythagoras theorem.
Very good. What did you do? Can you tell us?
5 squared plus minus 3 squared.
And then
And then
square root.
equals square, yeah.
Yeah, okay. So equal to square root of what?
16.
16. Okay, very good. And because it's on the left side, don't forget you need to have a negative. Okay.
Okay.
So therefore, cosine of angle A should be what over what?
Let's see. -4/5.
Yeah. Okay, very good, Waylon. So if you're missing, so first thing you look at the angle, right? If it's angle A, you look at the top picture. If it's angle B, you look at the bottom picture. And if you are missing one of the sides, you use Pythagoras theorem. Okay. And you can see the sign. This one is negative, right? So remember, for second quadrant, only sine is positive, sine or cosecant, positive, right? Everything else should be negative, so it checks, right? Any question how we got the first blank? Okay, so I'll let you finish the other 3 blanks. I think I made a mistake here, right? The last one should be B, right? Did anyone see that? Okay, AB, right? Coco, change sign. Okay, so please fill in the 3 other blanks and raise your hand, right? If you still have question how we got the first bracket, okay, let me know. Okay, if you found out all 4 blanks, please raise your hand. Check that first before you simplify it. Okay, we'll check the second one first. Marcus, what's the second blank?
Isn't it -5/13?
Very good. Okay, so this one is given, right, in the question. Cosine B is -5/13. So that one we don't need to do anything. Okay, sine A, the third one. Claire?
3/5.
Yeah, so that one is also given. Okay, very lucky. Okay, we have last one. If you got the last one, please raise your hand. Jenny? Which part are you working on, Jenny? Jenny, are you back? Okay, how about you, Angela? Are you done with the last blank?
I don't think I did it right, but I got 4/13.
4/13. Where did you get a 4?
The Pythagorean theorem.
Okay, can you show us how you did the Pythagoras?
-5 squared plus b squared equals 13 squared.
Okay, hold on, let me write it down. Okay, negative. Okay, sorry, I'm yeah. Okay, -5 square. It's a little bit lagging here. -5 square, and then
Oh, wait, sorry. I got a 12/13. I realized I did it wrong.
okay, yeah.
Plus b squared equals 13 squared.
Okay, 13 square, and then
So it's 25 plus b squared equals 169.
yeah.
So it's b squared equals 144.
Yeah, okay, so B should be
12.
12, yeah, okay. So we have sine of B will be 12 over 13. Okay. So now all you need to do is just simplify these four fractions, okay? Follow the order of operation, right? Multiply and then subtract them, right? So at the end, you will get one fraction. Okay, so I'll leave that one for you guys to do again, all right? You can use your calculator if you like, right? Even though I think it's should be manageable, right? Just multiply fractions, subtract them. Okay, please raise your hand if you got the final fraction. Okay, Jenny, what's the answer?
I got negative 16 over 65.
Yeah, negative 16 over 65, okay? Anyone else has a different answer? So this is another way they could test you to see if you know how to use identity, okay? So as I mentioned before, this question does not need you to find the angle, okay? You don't need to know what the angle A is or angle B. All you need is to draw the picture out, figure out what the ratios are, okay? They give you enough clues so you can get the ratios, okay? Our final goal is to get the ratios. The other question we did before, they give you special angles, right? So you use the angles to find it. This one, you use the ratio to get ratio. Okay, that's the difference. So I'll give you a similar one on the right-hand side, okay? So this time is in the fourth quadrant. Okay, and same thing, they give you sine, they give you cosine. Please find tangent of A minus B. Okay, for this one, to save time, okay, we won't simplify it, okay? Just get to the final point before rationalize, okay? Don't worry about rationalizing, but you want to simplify it so yeah, because this one is tangent, right? So the expression will be a little bit more complicated. Okay, so just go as far as you can. We'll talk about simplifying, okay, together. Okay, is there anyone still have questions, still working on A? Can you raise your hand if you're still working on A? Okay, if you're all done, we're gonna move to B now, okay? Tangent difference, right? So I hope by now you remember tangent difference is something over something, right? Difference over 1 plus product. Okay, you can raise your hand once you get to this place, okay? Once you fill in the 4 blanks. Okay, we'll go over how to simplify this together. Remember, it's in the 4th quadrant. So some of the ratios will be negative. Well, actually, tangent is negative there, right? So all the ratio, remember, is negative. Only cosine is positive there. Fourth quadrant. This one's it's not difficult to fill in the blanks. The hard part is simplifying. Okay, so if you want to give it a try, you can start simplifying. Otherwise, if you're not sure, we'll go over it together. Okay, so please raise your hand if you got the 4 blanks.
Can you walk us through how to get the blanks because I'm confused?
Okay. Did you understand how we get the blanks on the left side?
Yeah, I think so.
So you have to get it from the 2 pictures on the left, right? You have to fill out the 3 sides on the 2 triangles, and then use that to get the blanks. Do you know how we
Okay.
got the sides of the triangles? Do you know?
Yeah, Pythagorean theorem.
Yes, okay. So after you get the 3 sides, okay, for question B, can you tell me the 3 sides for the triangles, okay, when you found them, all right? We'll check the sides first,
Okay.
okay? Yeah, if you got the 3 sides, let me know.
Okay, I have the 3 sides.
Okay, so for angle A, how long is the hypotenuse?
It's 3,
Yeah, and what about opposite?
1,
Yeah, and adjacent?
root 8.
Okay, if it's root 8, you could simplify it, right? Root 8. Root 8, do you know how to simplify that one?
Yeah, is it 2 radical 2?
Very good. Okay. And did you also finish cosine B for angle B?
Yep.
Okay. What are the 3 sides? Hypotenuse,
5.
and then
2 is the adjacent,
yeah.
and then I have root 21.
Okay, very good. So you just use the 3 sides for each triangle and then you can fill in the blank. Do you know how to do that?
So tan A would be 1/2√2.
Very good. Okay. And then remember, it's in the fourth quadrant, so tangent should be,
Hold on. Negative?
yeah. Okay, only cosine and secant is positive there. Everything else will be negative. So you do the same thing, okay? You can fill in the rest.
Okay,
Okay,
thank you.
yeah, you're welcome. All right, how's everyone else doing? If you got all the 4 blanks, please raise your hand. And then we'll start simplifying. If anyone has questions about how we got the 3 sides in the triangle, let me know. Okay, Nick, do you have the numerator, second blank in the numerator? Nick,
I think it's wrong though.
did you check the 3 sides in the picture?
Wait, for which one?
For this question, you have 2 triangles, right?
Yes.
Yeah, can you check the 3 sides? Are they the same as the ones you got?
For like which sine what? Like is it
For-
like sine A or cosine B?
Both. I want you to check both. Are they both correct? The same as yours?
No,
Which one you got different?
both.
Okay, then we need to find out how to get it, right? Do you know how we got the 3 numbers on each picture?
From like the perfect.
From where? Okay, we'll look at one picture at a time, okay? For sine A, do you know where we, do
Sorry.
you know how we got number 3 from sine A?
Because sine A is equal to -1/3 and sine is opposite over hypotenuse.
Yeah, so you put the opposite as 1, hypotenuse is 3, right?
Mhm.
So is that what you got on your picture?
No.
What did you put?
Oh, I put one as the adjacent.
Oh, okay. Yeah, so sine is opposite, right? And do you know how we got the 2 square root 2?
Yes, because it's like like Pythagoras' theorem, and then you like take out the 2.
Yeah. Okay. And for cosine B, it's the same way. Adjacent over hypotenuse. So adjacent is 2, hypotenuse 5. Okay?
Okay.
Okay, so using those 2 pictures, we can fill out the blanks. Okay, so you can tell me the second blank in the numerator, right? When you're ready.
So is the second blank root 21/2?
Close, very close. It's in fourth quadrant.
Oh, negative root 21 over 2.
Very good. Yeah. Okay. And then the bottom, it will be like a copy of the top, right? Because 1 plus product. Product means you multiply the tangent A with tangent B. Okay, so everyone should got here by now. But then the problem is how to simplify it. Okay, so let's simplify the top first. The top has a subtract a negative, so we're gonna just write it as plus, right? So 1 negative 1 over 2 root 2 plus root 21 over 2. The denominator, we will just multiply those two together, right? The two fractions. So 1 plus product, okay? Negative times negative will give you positive. Numerator times numerator, so that's square root 21 over 4 root 2. When you multiply outside number times outside number, right? So 2 times a 2 on the outside. Okay, can you raise your hand if you understand up to here? Okay, don't want to go too fast. Still looks complicated, right? So that's not the final answer we want to leave it in. Okay, please raise your hand if you got everything up to here. Okay, Susan, Marcus, and Jocelyn, any questions? All right, so we have what's making it looks difficult is the denominators, right? We have a lot of denominator in the fractions, right? In the numerator and the denominator, right? So we want to get rid of them. So you look at all the denominator. 2 root 2, right? You have the 2, you have 4 root 2. So we use the common denominator of them, which is 4 root 2, right? 4 root 2 will be covering all of them. We multiply the top by 4 root 2, the bottom by 4 root 2. Okay, both top and bottom times the same thing. So when you distribute, right, when you multiply with the first one, it will cancel out the denominator, right? Root 2 will cancel out, 4 and 2 can reduce. So the top will give you negative 2. Okay, stop me anytime if any step you got confused. Okay, and then for the second fraction, when you multiply with the second one, the 4 will cancel out with the 2, right? So we'll leave a 2 on the outside. And then inside times inside, so root 42. Any questions so far? We're gonna move on to the second one, okay? Second one, same thing, we multiply with the 1, so that gives us 4 root 2. For the second one, you just have root 21. Okay, of course you can do the rationalized denominator multiply conjugate, okay? But we're not gonna do that, okay? We can leave the answer like this. But if you actually do the multiply conjugate, okay, your final answer should look like this. Okay, if you continue more steps, all right, multiply by conjugate. Like what we did before, like where do we do that? Like over here, right? The red one, 1 minus root 3 times 1 plus root 3, okay, multiply conjugate. Then you will be able to simplify the square root at the bottom. Okay. So your final answer should end this. Okay, but that takes a lot of more multiplying. Okay, so we're gonna skip those details right now, but just to let you know, this dot 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 is to multiply by conjugate. Okay, so let's have a break first. Okay, after the break, we're going to learn more identities. Okay, so that's all for the sum and difference. So we'll come back at 11:20 then. Okay, 11:20.
Jason, could I see the first